Solar-powered parking lot control gates are indeed available and often used in situations where access to alternating current power is limited, such as remote parking areas or locations not connected to the electrical grid. These gates function by converting sunlight into electricity using solar panels. The generated electricity powers the gate's motor and related components. Typically, the solar panels are installed either directly on the gate structure or on a nearby pole or building. The use of solar-powered parking lot control gates presents several advantages. Firstly, they are cost-effective. Because they operate independently of the electrical grid, there are no ongoing electricity costs associated with their operation. This can result in considerable savings over the lifespan of the gate system. Secondly, they are environmentally friendly. By utilizing solar energy, these gates operate without producing any emissions, contributing to a reduction in carbon footprint and promoting sustainable practices. Thirdly, they are relatively easy to install and maintain. Installation typically involves mounting the solar panels and connecting them to the gate's control system. Maintenance is generally low, primarily consisting of occasional cleaning of the solar panels to ensure optimal performance and periodic inspections of the gate mechanism. Several companies manufacture solar-powered parking lot control gates. A few of these companies include FOC, KEM, BFD, NICE, and High Security. When considering a solar-powered parking lot control gate, it is important to assess the specific requirements of your location. Factors to consider include the amount of sunlight available, the size and weight of the gate, and the desired frequency of operation. It is also important to select a reputable manufacturer with a proven track record of producing reliable and durable solar-powered gate systems. The selection of a solar-powered parking lot gate involves understanding several key technical aspects. Firstly, solar panel sizing is critical. The size of the solar panel array must be sufficient to generate enough power to operate the gate reliably, even on cloudy days. The size will depend on the gate's power consumption, the local solar irradiance, and the amount of autonomy required. Secondly, battery storage is important. Solar-powered gates typically incorporate a battery bank to store energy generated by the solar panels. This ensures that the gate can operate even when sunlight is not available. The battery capacity must be carefully chosen to meet the gate's power demands during periods of low sunlight. Thirdly, gate motor selection matters. The gate motor should be energy efficient and sized appropriately for the weight and size of the gate. Look for motors designed for continuous operation and with built-in overload protection. Fourthly, the charge controller is a critical component. A charge controller regulates the flow of energy from the solar panels to the batteries, preventing overcharging and extending battery life. It is important to select a charge controller that is compatible with the solar panels and batteries used in the system. Fifthly, the gate control system incorporates logic to manage gate operation, including opening, closing, and safety features. The control system should be reliable, easy to program, and capable of integrating with access control systems such as card readers or keypads. Sixthly, safety features are important. Safety features such as photo eyes and loop detectors are essential to prevent the gate from closing on vehicles or pedestrians. These features should be installed and maintained in accordance with safety standards. Considering wireless communication for card swipes introduces another layer of technical considerations. Firstly, wireless range needs to be sufficient. The wireless range of the card reader system must be sufficient to cover the entire gate area, ensuring that users can reliably activate the gate from their vehicles. Secondly, wireless security is paramount. The wireless communication between the card reader and the gate controller must be secure to prevent unauthorized access. Encryption and authentication protocols should be used to protect against hacking. Thirdly, power consumption of the wireless system should be low. The wireless card reader and controller should be energy efficient to minimize the load on the solar power system. Consider using low-power wireless technologies such as Bluetooth Low Energy or Zigbee. Fourthly, weather resistance is important. The wireless components must be weather resistant to withstand the outdoor environment. Look for devices that are rated for outdoor use and can operate in a wide range of temperatures. Fifthly, integration with the gate controller needs to be seamless. The wireless card reader system must be compatible with the gate controller and easy to integrate. The system should provide clear feedback to users, such as visual or auditory signals to indicate when the gate is activated. When evaluating solar-powered parking lot control gates, it is important to consider the total cost of ownership, including the initial purchase price, installation costs, maintenance costs, and energy savings. Compare the total cost of ownership of a solar-powered gate with that of a traditional alternating current-powered gate to determine the most cost-effective solution for your specific application. Consider the environmental benefits of using a solar-powered gate, such as reduced carbon emissions and energy consumption. Solar power is a renewable energy source that can help to reduce your environmental impact. Review the warranty and support services offered by the manufacturer. Choose a manufacturer that offers a comprehensive warranty and provides excellent technical support. Check references from other customers who have used the manufacturer's solar-powered gate systems. This can provide valuable insights into the reliability and performance of the products. Ensure that the solar-powered gate system meets all applicable safety standards and regulations. This will help to ensure the safety of users and prevent accidents. Consider the aesthetics of the solar-powered gate system. Choose a design that complements the surrounding environment and enhances the appearance of your property. Think about the long-term scalability of the solar power system. Can the system be easily expanded in the future if your power needs increase? Get quotes from multiple manufacturers and compare the features, prices, and warranty terms. This will help you to find the best value for your money. Evaluate the installation process and ensure that the installer is experienced in installing solar-powered gate systems. A professional installation will help to ensure that the system operates reliably and efficiently. Ask the manufacturer or installer about any available rebates or incentives for solar-powered gate systems. There may be government or utility programs that can help to reduce the cost of the system. A solar-powered gate can be a reliable solution provided it is properly designed, installed, and maintained. Proper planning is key for long-term trouble-free operation. When considering the wiring and electrical aspects of a solar-powered gate system, several factors must be taken into account to ensure safety, efficiency, and compliance with the electrical codes. Firstly, proper grounding is essential. The entire system, including the solar panels, batteries, charge controller, and gate motor, must be properly grounded to protect against electrical shock and prevent damage from lightning strikes. Grounding should be done in accordance with the National Electrical Code, specifically Article 250. Secondly, overcurrent protection is critical. Fuses or circuit breakers must be installed in the system to protect against overloads and short circuits. The size of the overcurrent protection devices should be selected based on the ampacity of the conductors and the rating of the equipment. NEC Article 240 provides guidance on overcurrent protection. Thirdly, wiring methods should comply with NEC standards. All wiring must be installed in accordance with the NEC. This includes using appropriate wiring types, conduit, and fittings. Underground wiring must be buried at the proper depth and protected from physical damage. Refer to NEC Chapter 3 for wiring methods and materials. Fourthly, disconnect switches are important. A disconnect switch should be installed to allow the system to be safely de-energized for maintenance or repairs. The disconnect switch should be readily accessible and clearly labeled. Fifthly, surge protection is necessary. Surge protection devices, SPDs, should be installed to protect against voltage surges caused by lightning or other electrical disturbances. SPD should be installed at the solar panels, charge controller, and gate controller. NEC Article 280 covers surge protection requirements. Sixthly, battery safety is important. Batteries should be installed in a well-ventilated enclosure to prevent the buildup of flammable gases. Battery terminals should be protected against accidental short circuits. Follow manufacturers' recommendations for battery handling and maintenance. Seventhly, conductor sizing must be correct. Conductors must be sized appropriately for the amount of current they will carry. The ampacity of the conductor should be at least 125% of the continuous load. NEC Table 310.15 provides guidance on conductor ampacity. Eighthly, labeling should be clear. All components of the system, including the solar panels, batteries, charge controller, disconnect switches, and overcurrent protection devices, should be clearly labeled to indicate their function and voltage rating. Ninthly, inspection should be performed. The system should be inspected by a qualified electrician to ensure that it is installed correctly and meets all applicable codes and standards. Regular inspections should be performed to identify and correct any potential problems. Tenthly, documentation should be thorough. Complete documentation of the system, including wiring diagrams, equipment specifications, and inspection reports, should be maintained for future reference. When selecting a wireless communication system for card swipes, consider the following technical requirements. Firstly, frequency band. The wireless system should operate on a frequency band that is not prone to interference from other devices. Common frequency bands for wireless communication include 900 MHz, 2.4 GHz, and 5.8 GHz. Secondly, communication protocol. The wireless system should use a reliable communication protocol such as Wi-Fi, Bluetooth, Zigbee, or LoRaWAN. The choice of protocol will depend on the range, data rate, and power consumption requirements of the application. Thirdly, encryption. The wireless communication should be encrypted to protect against unauthorized access. Common encryption algorithms include EASE and RSA. Fourthly, authentication. The wireless system should use authentication to verify the identity of the card reader and the gate controller. Common authentication methods include passwords, digital certificates, and biometrics. Fifthly, range. The wireless system should have sufficient range to cover the distance between the card reader and the gate controller. The range will depend on the frequency band, transmit power, and antenna gain. Sixthly, data rate. The wireless system should have sufficient data rate to transmit the card swipe data quickly and reliably. The data rate will depend on the amount of data being transmitted and the communication protocol. Seventhly, power consumption. The wireless system should be energy efficient to minimize the load on the solar power system. Consider using low-power wireless technologies such as Bluetooth Low Energy or Zigbee. Eighthly, security. The wireless system should be secure to protect against hacking and unauthorized access. Implement security measures such as firewalls, intrusion detection systems, and regular security audits. Ninthly, reliability. The wireless system should be reliable and able to operate in a variety of environmental conditions. Choose components that are designed for outdoor use and can withstand temperature extremes, humidity, and vibration. Tenthly, maintenance. The wireless system should be easy to maintain and troubleshoot. Choose components that are modular and easy to replace. Provide training to personnel on how to maintain and troubleshoot the system. Solar-powered parking lot gates offer a practical and sustainable alternative to traditional alternating current powered gates. A thorough understanding of the technical aspects related to solar power, gate operation, and wireless communication will ensure successful and reliable implementation. When working with electrical systems, always prioritize safety. Consult with qualified electricians and follow all applicable codes and standards. Consider consulting with a solar energy expert to help you design and size the solar power system for your parking lot gate. They can assess your specific needs and recommend the best solution for your location. Remember to factor in local weather conditions such as average daily sunlight hours when designing the solar power system. This will help ensure that the gate operates reliably year-round. Regularly inspect the solar panels for dirt, debris, and shading. Clean the panels as needed to maintain optimal performance. Monitor the battery voltage and state of charge to ensure that the batteries are functioning properly. Replace batteries as needed, following manufacturer's recommendations. Keep the gate mechanism clean and lubricated to ensure smooth operation. Inspect the gate for any signs of damage or wear and tear. Repair or replace damaged components promptly. Check the wiring and connections regularly to ensure that they are tight and secure. Look for any signs of corrosion or damage to the wiring. Test the safety features, such as photo eyes and loop detectors, regularly to ensure that they are working properly. This will help prevent accidents and injuries. Keep the area around the gate clear of obstructions to ensure that the gate can operate smoothly. Trim any vegetation that may be blocking the solar panels or interfering with the gate operation. Train personnel on how to operate and maintain the solar-powered parking lot gate. This will help ensure that the gate is used properly and that any problems are addressed promptly. Keep records of all maintenance and repairs performed on the solar-powered parking lot gate. This will help you track the performance of the system and identify any potential problems. By following these tips, you can ensure that your solar-powered parking lot gate operates reliably and efficiently for many years to come.